As we go through the question, I'm going to leave a slight pause every now and then so you can stop the video, have a go for yourself and see if you got the answer correct. So it says this question is about the electrolysis of molten potassium chloride. Give a definition of electrolysis. Well, electrolysis has two parts to the word: electro, which means to do with electricity, and lysis, which means splitting something apart. So electrolysis is the process that uses electricity to split apart a compound. Question B. On the diagram of the electrolysis cell, label the anode and the cathode. Well, for this question, we need to remember panic, which stands for positive anode and negative is cathode. So if we label that on the diagram, the positive side connected to the positive side of the power pack is the anode and the negative side is the cathode. Question C. What would be made or discharged at each electrode? So on this question, I would encourage you to draw the ions involved on the diagram. If there isn't a diagram, quickly sketch one on your exam paper somewhere. And because we've got potassium chloride, we've got potassium ions and chloride ions. Potassium is in group 1 of the periodic table, so it forms a 1+ ion, K+. Chlorine is in group 7 of the periodic table, so it forms a 1- ion. We also need to remember that opposite charges attract, so the positive ions go to the negative electrode and the negative ions go to the positive electrode. So that means that the positive potassium ions will move towards the negative cathode. So potassium is made at the cathode, and the negative chloride ions will move towards the anode, so chlorine is made at the anode. Question D. What would happen if you use solid potassium chloride instead of molten potassium chloride? Explain your answer. Well, it would not work as it would not conduct electricity because the ions are not free to move when it's a solid. Question E. Why would the potassium chloride have a high melting point? Well, this is typical of where sometimes the examiners mix up the topics a little bit, so they throw it in here, part of the structure and bonding topic, because it's relevant to this question. If you need a reminder about the properties of ionic compounds, I'll put a link up here now to a previous video. So the answer is, the ions are held in place by strong electrostatic forces of attraction that need a lot of energy to overcome them or to break those forces. This part of the question is for higher tier students only. So question E, finish the half equation for what happens at the cathode. So we can see potassium is a K+, so we're going to need to use one electron somewhere. Do we put the electron on the left of the arrow or do we put it on the right? Well, in this case, it goes on the left of the arrow because the charge needs to balance. If we look at the left-hand side of the equation, 1+ and 1- cancels out, so that's 0 charge, and we've got no charge on the right-hand side. Is this oxidation or reduction? And explain it in terms of electrons. So we need to remember oil rig, which stands for oxidation is loss of electrons and reduction is gain of electrons. Now in the equation it's saying K+ ion and an electron turns into K. So some people can spot straight away that K+ is gaining an electron and therefore it's reduction. However, if you're struggling to see that, you can use oxidation numbers. And I'll put a link up here now to a previous video about how we can use oxidation numbers. But in this question, it's essentially the same as the charge. Potassium is a 1+. That's the potassium ion on the left, whereas the potassium atom on the right is 0 oxidation number. So we're going from a +1 to a 0, so it's reducing. So that is reduction. Once we know it's reduction, we can go back to oil rig, and we know that if it's reduction, it must have gained electrons. Question F. Write the half equation for what happens at the anode. So all the time in electrolysis, we have ions changing into atoms. So we've got a Cl- ion changing into a Cl atom. So again, we've got a 1- charge, so we've got to put one electron somewhere. Does it go on the left? Does it go on the right? Well, in this case, we need to put it on the right because then it will balance on each side. We've got one minus charge on the left, one minus charge on the right. But there's a second stage to this equation because all of the halogens like chlorine, bromine, iodine in group 7 are what we call diatomic molecules. That means they go around in pairs. So if we're going to form a Cl2 molecule, we need to double up on everything else. So we need to start with 2 chloride ions, and we'll also have 2 electrons made at the end. Is it oxidation or reduction? Well, if you're one of those people that can spot that the chloride ion is losing its negative charge and therefore losing electrons, then you go back to oil rig and we can see that losing electrons must be oxidation. However, if you can't spot that from the equation, we use the oxidation numbers, and Cl minus is a -1 and it's going to Cl, which is 0, no charge. So it's going from -1 to 0, so the oxidation number is increasing, and in that case we can say it's oxidation. And once we know it's oxidation, from oil rig we know it must have lost electrons. So if you found the video useful, please remember to give it a like and don't forget to subscribe so you don't miss out on future videos. Thanks for watching.